Welcome back to the course. This is Introduction to Azure Networking, and this is Lesson 8, where you'll deploy your first Azure hub and spoke topology. By way of introduction, just a quick recap that links to the prerequisites for the course can be found in the Introduction section, and links to the deployment scripts which are hosted on GitHub can be found in the Resources section. This lesson comprises two parts. In part 1, you'll learn how to create a hub resource group to further split our deployment across multiple containers for better organisation, how to create a hub virtual network with subnets to provide connectivity for Bastion and a virtual network gateway, how to recreate the Bastion in the hub virtual network, and how to create a virtual network gateway in the hub virtual network. In part 2, you'll learn how to create peering relationships between the hub and spoke virtual networks, how to create and associate a route table for each subnet in each spoke virtual network, how to populate each route table with user-defined routes to the other spoke virtual networks in the topology, how to connect to each virtual machine via Bastion in the hub virtual network, how to verify connectivity between virtual machines across the hub and spoke topology, and finally, we'll recap on the effective routes and effective security rules of the network interfaces so you can understand how routing and filtering works in a hub and spoke topology. Let's review the topology diagram for this lesson. First, let's recap on the resources that we're reusing from the previous lessons. These include the first, second and third resource groups, their virtual networks and their subnets, and their virtual machines and their associated resources. We now also have a hub resource group, a hub virtual network with two subnets. We've added a virtual network gateway with its associated public IP address attached to the dedicated subnet, and we've recreated the Bastion and its associated public IP address also attached to its dedicated subnet. In the second part of our deployment, we'll create the peering relationships necessary to establish the hub and spoke topology, and we'll add the route tables with user-defined routes to the subnets in the spoke virtual networks in order to leverage the gateway in the hub virtual network. And now let's see what this looks like in the Azure portal once everything's been deployed. Here we are in the hub resource group view, and we can see a list of the resources that we've deployed. From the top, we have the Bastion and its associated public IP address. Next, we have the virtual network gateway and its associated public IP address. And finally, we have the hub virtual network. Next, we have the resource group for the first spoke, and again, from the top, we have the network security group for the first subnet, the route table for the first subnet, the first virtual machine, its operating system disk and its network interface, and the first virtual network. Next, we have the resource group view for the second spoke, and we have exactly the same resources deployed as in the first spoke. And finally, we have the resource group view for the third spoke, and again we have exactly the same resources deployed as in the first and second spokes. Now it's time for our demonstration, so let's get started. Here we are in Visual Studio Code. We have the first deployment script open, and our terminal is ready. As usual, before we execute the script, let's review it so we can understand what it's doing. From the top, we have our variables. We're going to recreate the Bastion in the hub, so we'll be deleting the instance in the first virtual network, along with its associated public IP address and its subnet. To do this, we need the resource group, location, and name of the virtual network, along with the name of the Bastion subnet and the name of the Bastion and its associated public IP address. Next, we're going to create the hub resource group, so we need its name. We're then going to create the hub virtual network, along with its subnets for the virtual network gateway and the Bastion. For this, we'll need their names and their address prefixes. Next, we'll create the virtual network gateway and its associated public IP address, so we need their names. And finally, we'll recreate the Bastion and its associated public IP address, so we'll also need their new names in the hub. Now we have our variables defined, we can begin creating our resources. First, we'll delete the existing peering relationships that were used to create the mesh topology in the previous lesson. To do this without using 6 individual delete commands, we can reuse some of the scripting techniques we started to learn in Lesson 6. Fortunately for us, there is a list command which will return all of the virtual networks within an Azure subscription. We'll format the output using JSON, then we'll use the convert from JSON commandlet to return an object, which we'll then store in a variable. Don't worry if you can't remember how to iterate over an object. We'll recap this here, and we'll also extend our scripting knowledge by introducing nested loops. In the first loop, we'll iterate over each virtual network within the virtual networks object. We know that each virtual network currently has a pair of peerings in order to create the full mesh topology. Within the first loop, we'll extract the peerings from the object, which we'll store in another variable. And then, in the second loop, we'll iterate over each of the peerings. Within the second loop, we'll extract the name and resource ID of each peering. We'll then delete the peering by providing its resource ID. Next, we'll delete the Bastion. We can do this by providing its name and resource group. We'll then delete the public IP address associated with the Bastion. We can also do this by providing its name and its resource group. We can then delete the Bastion subnet. For this, we need to provide the name and resource group of the virtual network, along with the name of the subnet. Next, we can create the hub resource group. This requires its name and location. Then we can create the hub virtual network. This requires its name and resource group, along with its location and address prefix. We can then create the subnet for the virtual network gateway. For this, we need the name and resource group of the virtual network, along with the name and address prefix of the subnet. We can also create the subnet for the Bastion. For this, we also need the name and resource group of the virtual network, along with the name and address prefix of the subnet. Next, we can create the public IP address for the virtual network gateway. To do this, we need its name, resource group, and location, along with its skew and allocation method. We can then create the virtual network gateway. For this, we need its name, its resource group, and its location, along with several other parameters. These include its skew, the gateway type and generation, the VPN type, its virtual network, and its public IP address. We can then recreate the public IP address for the Bastion. To do this, we need its name, resource group, and location, along with its skew and allocation method. And finally, we can recreate the Bastion itself. For this, we need its name, resource group, and location, along with its skew, its virtual network, and its public IP address. Optionally, we can enable tunneling, which will allow us to connect via the Azure portal and via the command line using the Azure CLI. We can now execute the first script, which will deploy the resources. Here we are again, back in Visual Studio Code, this time with our terminal window maximized. Just a quick side note here, when specifying the virtual network gateway, we use the no-wait parameter to ensure the script completes execution promptly. Please be aware that gateways can take anywhere from 15 to 45 minutes to complete a successful deployment. Let's execute the first script and observe the deployment. If you're following along, in a moment you may wish to pause the video here until the deployment is complete on your side. Just a quick side note here, if you're following along, don't be alarmed if you think the deployment script has hung when it comes to deleting the Bastion instance in the first virtual network. This can take anywhere from 5 to 15 minutes to complete, so please be patient. Now our first deployment is complete, let's change over to the Azure portal to review our resources. Here we are in the Azure portal in the Hub Resource Group view. Let's review the virtual network. Under Settings, we'll review the address space. Here we can see that the Hub virtual network is assigned 10.0/16. Let's also review the subnets. Here we can see that the gateway subnet is assigned 10.0.0/24, and the Azure Bastion subnet is assigned 10.0.1/24. And finally, let's go into the peerings. Here we can see that we've not yet created the peering relationships that will establish the hub and spoke topology. This will come in part 2. Let's go back to the resource group view, and let's review the Bastion. Here we can see the Bastion is in a succeeded state, and it's associated to the Azure Bastion subnet within the Hub virtual network. Let's again go back to the resource group view. And let's review the virtual network gateway. Here we can see that the gateway has been deployed and that it is associated to the hub virtual network. Now that we've reviewed our resource deployment, let's return to Visual Studio Code to review the second deployment script. Here we are back in Visual Studio Code. We have the second deployment script open and our terminal is ready. As usual, before we execute the script, let's review it so we can understand what it's doing. From the top, we have our variables. We're going to be creating route tables for our spoke virtual networks. For this, we need the deployment location. We're also going to be creating peering relationships to the hub, so we need the name of its resource group and its virtual network. The rest of our variables will be dynamically generated throughout the remainder of the deployment script. Since we're going to be creating peering relationships between the hub and spoke virtual networks, we'll need the resource ID of the hub virtual network. We can obtain this using a show command, along with the name and resource group of the virtual network. We'll again use a query filter for the resource ID, which we can then store in a variable. We have 3 spoke virtual networks, which means we need to repeat the same configuration multiple times. We've already seen how we can use scripting techniques to solve this problem, but in this lesson we'll expand on this a little further to include the use of arrays, nested loops, and the switch statement. Previously, we've used list commands to return objects, store them in variables, and iterated over them using loops. It can sometimes be helpful to create our own simple data structures, in this case a list of items, commonly known as an array. Don't worry if this syntax is new to you, we'll go through it step by step. We can create an array using the @ symbol and a pair of parentheses. Inside of the parentheses, we can add the items to the array, typically 1 per line for readability. In our case, we want the array to contain the index numbers of the spoke virtual networks. We can provide these as string values, enclosed in double quotes, separated with colons. We're then storing the array in a variable. We'll then use a loop to iterate over the array. Inside of the loop, we'll add the commands that we want to execute. First, we'll dynamically create some additional variables. We're going to create a peering relationship to each spoke, so we need the name of the resource group and the virtual network. We're also going to create and associate a route table to the subnet in each virtual network. To do this, we need the name of the subnet and the route table. Since we're going to be creating peering relationships between the hub and spoke virtual network, we'll need the resource ID of the spoke virtual network. Again, we can obtain this using a show command, along with the name and resource group of the virtual network. We'll use a query filter for the resource ID, and then we'll store it in a variable. We can then peer the hub to the spoke. To do this, we need the name and resource group of the hub virtual network, the name of the peering relationship, the resource ID of the spoke virtual network, and the parameters to allow virtual network access and to allow gateway transit. Next, we can peer the spoke to the hub. To do this, we need the name and resource group of the spoke virtual network, the name of the peering relationship, the resource ID of the hub virtual network, and the parameters to allow virtual network access, to allow forwarded traffic, and to use remote gateways. We can then create the route table, which we'll associate to the subnet. For this, we need the name of the route table and its resource group, along with its location. The route table can then be associated to the subnet. For this, we need the name and resource group of the virtual network, along with the name of the subnet and the name of the route table. Also inside of our loop, we'll populate the route table with the user-defined routes so that we can direct traffic to the other spoke virtual networks via the gateway and the hub. The routes we create will vary between each iteration of the loop. To do this, we can initialize an additional variable, the value of which will change on each iteration. We could do this with conditionals, using a combination of if statements. However, there's a more elegant way, using a switch statement. Again, don't worry if this syntax is new to you, we'll go through it step by step. First, we use the switch keyword, and then inside of parentheses, we'll define a single expression to be evaluated. In this case, we'll evaluate the value of the variable that contains the index number of the spoke virtual network in the current iteration of the loop. And then, inside of curly braces, we'll define each of the possible values of the expression we have just evaluated. In this case, 0,1, 0,2, and 0,3. We place each of these on their own line, again for readability. Immediately following each possible value, inside of more curly braces, we define the actions we want to take when the value is matched. In this case, we want to create another new array, which we'll assign to another new variable. This array contains the index numbers of the spokes that we need to create routes for. In our topology, the first spoke requires routes to the second and third spokes, the second spoke requires routes to the first and third spokes, and the third spoke requires routes to the first and second spokes. Now that our switch statement is complete, we're going to nest another loop inside of our existing loop to iterate over the new array that was created by the switch statement. Inside of our second loop, we'll again dynamically create some additional variables. To create the route, we need the name of the spoke virtual network and its address prefix. We can then create the route by providing the name and resource group of the route table, the name and address prefix of the route, and the parameter to specify the next hop type, in this case the virtual network gateway. We can now execute the script which will deploy the resources. Here we are again, back in Visual Studio Code, this time with our terminal window maximised. Just a quick side note here, in part 1 we deployed the virtual network gateway, and we indicated that this can take anywhere from 15 to 45 minutes to complete a successful deployment. This second deployment script will not complete successfully if the gateway is not in a succeeded state, since the peering relationships created by this script explicitly depend upon the gateway, since we've specified the parameters to allow gateway transit and to use remote gateways. If your gateway is not yet in a succeeded state, please wait for this to complete before attempting the deployment in part 2. Let's execute the second script and observe the deployment. If you're following along, in a moment you may wish to pause the video here until the deployment is complete on your side. Now our second deployment script is complete, let's change over to the Azure portal to review our resources. Here we are in the Azure portal, back in the Hub Resource Group view. Let's review the virtual network. Under Settings, we'll review the peerings. Here we can see the peerings to all three of our spoke virtual networks. Let's review the first peering. Here we can see that the Hub virtual network is allowed to access the spoke virtual network, and the gateway in the Hub virtual network is allowed to forward traffic to the spoke virtual network. If we were to inspect the other peerings, we would see that the configuration matches. Why don't you try this for yourself? Let's now go into the first resource group view. And again, let's review the virtual network. Under Settings, we'll review the peerings. Here we can see we have a single peering to the Hub virtual network. Let's review the peering. Here we can see that the spoke virtual network is allowed to access the Hub virtual network. Also, the spoke virtual network is allowed to receive forwarded traffic from the Hub virtual network. And finally, the spoke virtual network is allowed to use the gateway in the Hub virtual network. If we go back into the first resource group view, let's now review the route table. We can see that the route table is associated to the subnet in the spoke virtual network. We can see that we have routes to both the second and third spoke virtual networks, both via the virtual network gateway. If we were to inspect the peering and route table configuration of the other spoke virtual networks, we would see that the peering configuration would match, and that the routing configuration would contain routes to the other spoke virtual networks. Why don't you try this for yourself? Let's now validate connectivity over our new topology. Here we are back in the first resource group view. Let's go into our first virtual machine, and let's choose Connect via Bastion. We'll enter the username and password for the virtual machine. We'll then choose Connect. And in our new tab, we can see that we have an SSH connection to our first virtual machine. Let's validate connectivity to the second virtual machine. Here we can see we've received a response to each of our requests. And now let's validate connectivity to the third virtual machine. And again, we've received a response to each of our requests. Next, let's try to connect to the second virtual machine. Here we can see we've been able to successfully establish a connection. And now, let's validate connectivity back to the first virtual machine. Here we can see we've received a response to each of our requests. And now, let's validate connectivity to the third virtual machine. And again, we can see that we've received a response to each of our requests. Next, let's try to connect to the third virtual machine. And as we can see, we've been able to successfully establish a connection. And now, let's validate connectivity back to the first virtual machine. Here we can see we've received a response to each of our requests. And finally, let's validate connectivity back to the second virtual machine. And as we can see, we've received a response to each of our requests. Let's review the effective routes and effective security rules so we can understand how our new topology works. Here we are back in the first resource group view. Let's go into the network interface of the first virtual machine. And let's view the effective routes. Here we can see that we have a 10.1/16 system route for the virtual network. We also have a 10.0/16 system route with the next hop type of VNet peering. This is the peer to the hub virtual network. Also note that we have two user-defined routes to 10.2 and 10.3/16 with the next hop type of virtual network gateway. These routes are to the other spoke virtual networks in the topology. And finally, we still have a quad 0 system route with the next hop type of internet. If we were to inspect the effective routes of the network interface of the second and third virtual machines, we would see routes for the respective virtual network and spoke virtual networks. Why don't you try this for yourself? Let's now review the effective security rules. Here we are in Network Watcher. Let's review the effective security rules. We'll select the first resource group, and then the first virtual machine, and then the network security group associated to the subnet. Here we can see the inbound and outbound rules, and we can observe that the virtual network tag now has two prefixes. If we select the virtual network tag, we can see that it includes the 10.0/14 prefix, which Azure has summarized to include 10.0, 10.1, 10.2, and 10.3/16. If we were to inspect the effective security rules of the network interfaces of the second and third virtual machines, we would see a matching prefix in the virtual network tag. Why don't you try this for yourself? That concludes this lesson. I hope to see you in the next one, where you'll deploy your first Azure VPN. See you next time.